Hello everyone, Mati here. In a lot of my more advanced videos, I've been using Spring Boot as a way to create a quick web application. And some people have reached to me saying, I don't know how to actually use Spring Boot. I don't know much about it. So can you create more videos about Spring Boot? And I was like, yeah, sure. So I wanted to create this video to show you guys what Spring Boot is and give you a quick intro. This is not by no means an exhaustive video on Spring Boot. Spring Boot is a huge framework and it has a lot of extensions, but it's really useful. It's widely used in the industry, so it's really good to know this tool and to have it in your tool belt. So I hope this video will help you to learn about Spring Boot and to incorporate it and look more into it because it's huge and it has a lot of different functionalities. Right, so what is Spring Boot? Spring Boot is basically a framework that was created by the people who develop Spring that uses Spring to create applications that can just run. They describe it like this. We take an opinionated view of the Spring platform and third-party libraries so that you can get started with minimum fuss. Most Spring Boot applications need minimal Spring configuration. And this is true. They take an opinionated approach. So what does that mean? It means that they are based on conventions that they themselves define. So if you want to use a Spring Boot application, you have to know these conventions. You have to know exactly what kind of things you have to follow, what kind of rules you have to follow in order for your application to run. If you want to create an extension for your Spring application, for your Spring Boot application, then you'll have to know what conventions to follow. But these are very easy to follow and we'll learn some of them. But yeah, they take this opinionated approach and they give you a lot of things out of the box if you follow this approach. So basically, if you follow that approach, then you'll have to do almost no configuration and you will get a lot of benefits. So, but first, what is a Spring exactly? Let's take a look at what Spring is. Spring is a framework that implements the concept of inversion of control. And what is inversion of control? Inversion of control is used to shift the control and the dependency management. So instead of having to know implementation details in advance, you can postpone that to the moment of runtime so that you can have more flexibility and it will give you more modularity, testability. You can externalize components and you can enhance the testability of the whole application. So I'll give you an example of this. I have created this application here, and this application is our Spring tutorial, and it's a bank account application. So basically you can create bank accounts and you can deposit money into those bank accounts. The application is really simple. It has something called the bank account where you have an ID for the bank account and the balance, and that's it. And you have a single method that deposits new money into the account, which basically returns the new account with the same ID but with the new balance. And then we have a bank account service, and the bank account service, what it does is it will process the transaction and it will basically look for the bank account in our bank account repository, which I will speak about it right now, and then it will update that bank account with the new balance. And the bank account repository is an implementation of a pattern called repository, where basically this interface allows us to access where we are storing stuff, where we are storing our entities, our objects. So usually applications store their objects in the database or in disk, in files, so or what have you. So you can access this data using the repository pattern. And this pattern gives you the flexibility that you can have an interface, and then you can have different implementations of that interface. So we can deal with different types of repositories. We can have a disk repository, we can have a JDBC, which is a database repository. So I created a database repository here, and I will be using MySQL for this tutorial. So I have a Docker Compose that I've used in multiple tutorials. So this Docker Compose has only MySQL. This will only run MySQL. And then I have the JDBC repository, which is the implementation of my bank account repository. So my bank account repository basically uses JDBC, which is the way in which we can access databases from Java. Is the Java standard for accessing databases, and I'm using it to access the database in this case. I won't go into detail on how to use JDBC because it's not the purpose of this tutorial. This tutorial is about Spring and Spring Boot, but I will be creating more tutorials in the future, and I could create one on JDBC as well. So, but what you have to know with JDBC is basically you have to create a connection to the database using the database information. In my case, my database is called bank, and it's located in my local host, and the user's root and the password's root. This is all for testing purposes. Of course, this won't go here in production code. This would go into a configuration class or in a configuration file and so on, you know. And so we create a connection, and then we create a statement and execute that SQL statement. For example, in this find by ID, what we do is we select from the bank account table the ID and the balance, and then we turn this into a bank account object with the result set. It's really simple. Then we have to handle the exceptions in the case that something goes wrong with the database. For example, maybe the database is not running, so it cannot connect. There could be a lot of things that could happen. So we handle the exceptions here. It's a very rudimentary handling of exceptions. I don't recommend this. This is just for our POC purposes. But then, so we find by ID, then we have another method to update the database, which is really simple as well. We create the connection, then the statement, and then we execute the update, which is updating the balance on the row. And I also have the database, and I have connected to the database using IntelliJ, but you can connect with whatever client you want. So in my case, I have this bank account table. I'm going to initialize it in 0. So to run this project, this is already running, but I could stop this this container. So this is already running in Docker, but I can stop this. Let's stop it. And now if I go to the Docker Compose, we can see the configuration of MySQL. I have the password for the root user, which is root, and then I have this init file that will run during the creation of the database, and it's going to create the schema, and then it's going to create the table bank account so that we can use it. We don't have to create that table in our application. so we can insert data. We'll have one record inserted with the value 0, so it won't have any money. So, but we'll have a bank account with ID 1, and it will be already there. So very simple. This then in our main, we'll basically have this part here is the declaration of the JDBC driver, so how we connect to the database. We have to do this. We cannot avoid it, so we'll leave it there. And then we create the bank account service. We call the method deposit. For the bank account with ID 1, we deposit the amount of 10. And then we find by ID and we print what is the amount that we have deposited. That's it. It's a very simple program. Let me run the database. So I'll run the Docker Compose here. And if we can see, okay. I want to show you what the program does, but I can understand that I'm going on a side path on the inversion of control matter, but I want to explain what the inversion of control is. Just bear with me, and once we have this running, I can show you what the application does. So let's see, if I run this, I'm depositing 10, right? So if I run this, okay, so I've run this and the balance for the account 1 now is 10. So if I run it again, I should get a different balance. Let's see, yeah, so now it's 20. And I can verify that very quickly going to the database and reading my bank account table, and I'll see now I have 20. If I run it again, I should have 30. Okay, so it's 30 here. And if I reload this data, I have 30 in the database. So great, the application works. So what I want to show you now is what I mean by inversion of control. So as I told you, I have my bank account service that uses the bank account repository to access the data. And how do I use it? I have the JDBC bank account repository here created, and then I can use it. What's the problem with this? The problem is that I am having to have a direct relationship between the bank account repository interface and the implementation. So it's hard for me to change the implementation of this because I had to have different to have a different implementation here. I would need to change it manually. So something like, I don't know, different impl bank account repository. But now I cannot switch back to the other one. I had to do it manually again. So imagine I want to test this class, for example. If I want to test this class, I would go on and create a test, right? I go here, I create a test for the method deposit. And what would happen? So if I do, for example, new bank account service, right? And then I can do bank account service.deposit. And I use the bank account with the number 1. And then I use big decimal 10, right? And I put it like this. Let's just say new bank balance. And I want to do an assertion on this. I would say assert equals. And then because I am using the actual database in my test, this data will be will have to be like resetted or something like that. I won't be able to, so I'll need to modify the database before and after the test so that it works. And what are the other disadvantages of this? Imagine the application, the database is not working. Imagine the database is not responding because it's the server crashed or whatever. I would get an exception on a test that I don't want to have an exception. And that violates one of the rules of testing, which is predictability. I need to make sure that my test will do what I want them to do, and they won't fail because of random things. So what we would usually do here is, instead of using the database, we would use a mock object, maybe use a mock framework like Mockito, or we could implement our own mock object. But because we are tying the implementation of the repository to the class, we are having a problem here. So how do we change this so that we can use a different implementation? Let's say let's create a mock implementation in our test folder. So let's say, for example, we want to use new bank account. Let's say new mock bank account repository, right? We do this and we basically say bank repo, and we create this class here. Look, I created it in the test part because it's a mock. I don't want this to be in my production code. And this is going to implement bank account repository, so it has to create all the methods for it. But this implementation is going to be very simple. I'm going to have a map here, private final map, integer, and bank account. And just call it accounts, and initialize it with a new hash map. Very simple implementation. So anytime I do this, let's say I find by ID, it's going to say accounts dot get. Then to say one, I'm going to say accounts put ID and bank account, and the same for the update. And that's it. That's a very simple implementation that is going to be more than enough for our test. And this is going to be way more efficient if I use it in my test. It will be faster. I don't really care about testing the database in this test because I'm testing, it's a unit test. I want to test the deposit method for the bank account service. So how do I apply the inversion of control principle? What I have to do is I'll go here, and instead of having this created in here, I'm going to remove this initialization, and I'm going to create a constructor with a repository as a parameter, right? So that's it. So now I have removed the responsibility of creating the bank account repository of the bank account service. It won't initialize it anymore, but now I have to initialize it somewhere else. So for example, in my main class, I'll have to initialize it something like new JDBC repository. And then in my test, because I don't want to use the actual JDBC implementation, I'm going to use my mock implementation. So you see how we can change easily implementations because we have we have inverted the way that we control the creation of the objects. And this is really good. This is one of the best principles that we have available for object-oriented design. So now, what I can do is I can quickly create before each, so a method that will run every time after every test. And I'm going to no, actually, let's not do that. So I have the repo, I have everything here. Right, so now I have a set equals, and I'm going to say big decimal 10. That's what I'm expecting, and the actual value will be my new bank balance. Sorry, I had to import the assertion. All right. So now, if I run this, what you will notice is, all right, so we have an error. Oh, sorry, I forgot to create it. Sorry, I forgot to create in my bank account repo. I can do it with my service, create bank account. Let's just do it in the repo. That makes more sense. Because we're preparing the scenario, so I'm going to save a new bank account with the ID 0, well 1, and with the value 0, so big decimal 0, right? And to make it a little bit more interesting, I'm going to do 2 deposits. So in here, I'm going to say value of 20. Oh, before we run this, let's change here and let's read from the repository directly. So I'm going to do bank this here and say bank account repo dot find by ID here. So the ID is 1. So that we know that the change was in the repository. And let's run this test. Okay, so as we can see, this has passed. And if I run this 1,000,000 times, it's going to still pass because this doesn't depend on a database being run. And also because it's in memory, this runs way faster than what a database would take time. And this might not be noticeable in this kind of in this one test, but if you start accumulating a lot of tests that are hitting the database directly, then you will start noticing problems in the performance. It's going to be less efficient. So excellent. So that's the concept of inversion of control. So basically, now we have made the bank account service independent of the implementation of the bank account repository. There's a beauty of this pattern, but this pattern can get a little complex if you try to implement it, and then you start noticing that if you have a chain of dependencies, for example, you have, let's say I want to create now a REST resource, right? I want to create a REST endpoint that is going to read from the database and it's going to return the data through HTTP in the JSON format. Now I have to create the REST resource or the REST controller class that will turn that data into JSON and so on. And that will have to have a reference to the bank account service, and that will have a reference to the bank account repository. And the creation will have to be done in the different order. For example, I have to create first the bank account repo, then create this one, and finally I'll have to do new bank account resource or controller, let's say. And so we'll have to keep track of this dependency management. Then, for example, this bank account repo might need some other dependency, or maybe I had to inject this very bank account repo to another service that also needs to use it. So that starts to become a headache for us to maintain. And that is where Spring comes into action. What does Spring does for you? Let me show you real quick. So Spring, in our naive approach, we created the bank account service and we instantiated the JDBC bank repository. Okay. Now with the inversion of control, with the Spring approach, what we do is we configure Spring so that it creates our objects, and then it will detect the dependencies of each object and will look for those objects and inject them. So for example, Spring will instantiate these two objects, right? And it will notice that this one doesn't have any dependency. So it will instantiate it, and then it will try to instantiate this one, but it will notice, hey, this one has a dependency on a bank account repository. So where can I get one? Oh, I have one. I have an object that implements this interface. So I'm going to inject it to this one. So that is extremely useful when you have multiple classes working together, because you don't have to keep track of all your objects. You just configure Spring, and Spring will do this for you. And this configuration is really easy to do in the newer version of Spring, and especially with Spring Boot, because it's mostly done through annotations. So you really don't have to do a lot. You have to just follow these annotations, and they will lead you to creating the whole context of your components. So in Spring, we talk about usually about the Spring context, where we have all our objects, our components, which in Spring are also called beans. So if you hear about beans in the context of a Spring, what we are talking about are these objects that are components of our application, and they need to be injected into other objects. So we create them, and we annotate them, we configure them so that Spring knows which objects are components of the application, and then we can reuse them in all of our other components. And I'm going to show you now how we can do that with Spring Boot. So what is Spring Boot? Spring Boot facilitates the creation of web applications, of any other kind of application as well, but mostly web applications. And what will you get out of the box? You will run the application in a Java server, like a Tomcat or a Jetty, and you will use Spring to initialize the application components. So you won't have to do this inversion of control on your own. You will use Spring to do it. It's very opinionated on how to configure your application. So you will get a lot of things out of the box, but the price that you pay is that Spring will have a lot of control on how the application is configured, so that you don't have to do it. And so it will have all the configuration for Spring libraries like Spring Web, Spring Security, Spring Data, and so on. And it's also very opinionated on how it uses third parties libraries. So you will have Spring Boot starter packs for Kafka, MySQL, and a lot of them. So it's very interesting. It really helps you to get going very fast. But yeah, you have to know that under the hood there's a lot going on. So I'm going to show you just we're going to refactor this application, this Spring application that we just created with the bank, and we're going to basically create a REST application out of the application that we have by adding Spring Boot, and I will show you how to use Spring to configure your application beans and how the inversion of control is going on, and then how we can create a simple REST application that will read the database and will return the data, the bank accounts, and we could update the bank accounts as well. So I will show you all of this right now. All right, so the first thing that we're going to do is we're going to modify our POM file with the dependencies that we need to have Spring Boot running. So one of the things that we need to do is add our parent POM, and this will tell the application to use as a parent POM the Spring Boot starter, and this is required for all Spring Boot applications. You need to inherit from this parent POM. It will have the initial configuration for Spring Boot in your application. And then we will add also a few dependencies for Spring Boot here. These dependencies are going to be I'm going to remove this Spring dependency here, and I'm going to have the Spring Boot starter web and the Spring Boot starter test, and that's it. And don't worry, because I'm going to be sharing this code, so you'll have access to this code. If you want to follow along, then I recommend you to download this code and use this branch base from the link that I'm going to put in the description. Okay, so I'll bring the dependencies from Maven. And so now that we have Spring Boot in our application, what I have to do is transform this into a Spring Boot application. So how do I do that? I'm going to go to the main object here. So I'm here in the main object, and I'm going to remove this. This is not going to be of use anymore. And I'm going to type this Spring application run. And I'm going to send this class and the arguments. We're not using arguments, but just in case, we can do that. And the other thing that we need to do is, and here's where the magic starts, we are going to annotate this as a Spring Boot application. So you see, we are starting to have our application as a Spring application. So now we can see in IntelliJ, the Ultimate Edition is going to show us that here we have a bean, an object that is going to have some configuration. And this configuration comes from the parent POM and all that. So Spring is going to do a lot of things under the hood. This is going to start an application server. It's going to run in the port 8080 by default. So I had to know all that. I had to know that it's going to start an application server, that is going to run in the port 8080, and it is capable of receiving HTTP requests and all that. So now that I have that, I have my bank account service, and I already did the inversion of control. So now you see in our main class, we're not instantiating any object. So how do we instantiate the bank account service and all the other stuff? I could do new bank account service and then new JDBC repository, and that would be okay. But since we're using Spring now, I'm going to let Spring do it. How do I let Spring do it? First, I'm going to have an annotation here. And remember, Spring is heavily reliant on annotations. And I'm going to use the service annotation. This just indicates Spring that this is a bean, which is also a service, right? So as you can see, now I have this icon here, and this tells me that this is in the Spring context. So now Spring is going to create this object. But now Notice I have here an error. It says could not auto-wire it. So what does auto-wire mean? It means that Spring is trying to inject this, but it doesn't have any object that fulfills this condition, which is it's an implementation of this interface. So how do I fix that? I go to my implementation here, and I can basically say component here. So I'm telling Spring this is a component of my application. And you see we have the icon here, the bean icon. So now this is a Spring bean. Now if I go back to my bank service, you notice there's no error. So it's by default using the constructor to inject. So Spring automatically will do this. Will first create the bank account repository, and then it will create the bank account service injecting that repository. And I can make it more explicit to Spring that it has to use this constructor by just using the auto-wire annotation. So this tells Spring, so you see these are Spring annotations, or Spring, beans, factory, and so on. This is telling Spring, use this constructor to inject the fields. This could be useful in the case that you have multiple constructors, for example. If you have multiple constructors, you need to tell Spring which constructor to use. In this case, we're using only this one, and because it had only one, Spring already knew which one to use. Okay, so now that we have our service and our repository, I am also going to create a new class called bank account controller. And another thing that I want to tell you about Spring is how does Spring know where to look, which classes it needs to look for annotations? And the answer is in this annotation here, Spring Boot application. You can define where it needs to scan for components. So you can say it has here scan base package. You see, by default it has a default value which is empty, so that means that Spring is going to look for anything in the same package and sub packages for this that this class is in. So for example, in this case, the main class is in this package, Programming with Mati. So it will look for anything in that class, in that package, sorry. But if I want to be more specific and I want to tell Spring which packages it has to look for components, I can use that annotation component base package scan base packages, and I can tell a list of different packages. I can send classes as well. I don't have to, because by default it will look for anything in this package and sub packages. So I'm going to leave it like this. So now, as I was doing, I created the bank account controller, you see? And this controller is going to be the class that will get the HTTP request, handle it, and then it will transform the result into JSON so that it can be returned to the HTTP response. And that is going to be done all by Spring. The main part that I'm going to do is just call the service and do the business logic. But then Spring will take care of creating a listener for the HTTP port, and it will send the request to this controller, and it will process it, and then it will transform our Java objects into JSON objects. Everything is done automatically by Spring, which is extremely awesome and really cool. So To do this, we're going to use the annotation REST controller, and this tells Spring that this is a special component. It is a component of the application context as the bank account service and the repository, but this is a special component because it's a REST controller. This will attend to particular REST requests. So if I can add another annotation called request mapping, and I'm going to put bank account, for example. So now any any calls to the HTTP port 8080 that has that URI, that this format here, is going to be redirected to the bank account controller. So now, if I say, for example, I want to create an endpoint to see the bank account that has a particular ID. So I can do this with a annotation called get mapping. And this is going to receive a parameter, which is the ID. You see, the ID of the bank account that I want to see. So public, and this is going to return a bank account. And let's say get by ID. Okay. And this is an int ID. So now we have to define how to translate this into this int parameter. We need to tell Spring, hey, this is actually, this is the same. So I'm going to say path variable. So because this variable is in the path, and the name of the variable is ID. So now it is linked to this variable here. So Spring will parse the URI and it will assign this value to this parameter. This is awesome because we don't have to do it. So now we have to call the bank account service to fetch our bank accounts. So private bank account service, and I'm going to put it final as well, and I'm going to initialize it through a constructor. And just to make it explicit, I'm going to put it auto-wired, so you know that this is being injected. You see, this bean is the same bean that I declare here with this service annotation. So I don't have to do this injection. Spring will do it for me. And now I can do return bank account service find by ID. And that's it. Now I could run this application and see that I can get this this bank account. So let's say let's run the application. And when we run the application, we'll see a lot of logging going on because Spring is going to be in action now. You see, Spring boot and all the logs, and we have started the application in the port 8080. So now I'm going to be using an application to test this called Postman. Postman allows me to send REST requests. So I have Postman open here. So if I do get here, let's call get. So you see I am calling localhost 8080, which is the port which Spring is using. I'm using bank/account/1. So if you notice, it's the same that we have in our controller. It's bank/account/the ID. right? So if I use a different ID, I'm going to have an error because I purposely have an error when there is nothing in the database. You see, internal server error. We need to handle it more gracefully, but there is an error. If I use one, excellent. So we are on a great track. Can you believe that Spring is transforming our object into a JSON? It's parsing the URI, redirecting it into the proper controller. Just magic. If you want to do this from scratch with native Java, it will take you a lot of time. So now that we have this running and we have everything working, let's add a new method here. And this new method is going to update. So it's going to be a put mapping. We're going to update here. Let's just call it deposit, because we want to deposit money in the bank account using the deposit method of the bank account service. So public bank account, we're going to return the bank account and then deposit, right? And this parameter, because it's a put method and I want to send a couple of information, I'm going to create a new object that will represent the request. So let's just call it bank transaction request. Okay. And I'm going to create as a record. Okay. And the bank transaction request will have int, which is the bank account ID. And it's going to have, let's just call it account ID. And then the other is going to be a big decimal. And this is going to be the amount. Very simple. And let's put it here. So now I'm going to say bank account service deposit. So the first argument is the account ID and the second argument is the amount. So transaction request amount. And I'm going to return the result of this. And one of the things that I need to tell Spring now is where's this thing coming from? You see, we don't have a path variable now. We want to put it in the body of the request as a JSON. To do that, we just simply use request body. And this annotation is a Spring annotation as well. And it's going to tell Spring, okay, this is going to come in the request body. And Spring doesn't really know if it is a JSON or an XML, but it will try to different formats. If it notices it is a JSON, it will translate it from JSON, which is amazing. So now I should be able to rerun this. And once it reruns, I can try this new method. Let's see. Okay, awesome. So I have created a put deposit here. So you see we have the request, which is the port 8080 bank / account / deposit. So this is what we have here, bank / account / deposit. And then we have a request body, the transaction here. So the transaction here, we are going to have the account ID and the amount. So I can say, for example, let's put 50. And I think we currently have 30 here, right? Yes. So if we have 30, we can, if we add 50, then we'll have 80. So let's try this now. And we have 80, which is fantastic. So now if I use the get method with the same bank account 1, you see 80. Awesome. And we can also verify that this is actually changed in the database. If I look into the database, I can see that the bank account is now in 80. So this is fantastic. I can actually change this on my own, for example, to 70. And now if I use the get method, I should get that amount. You see, 70. And this is the great thing about Spring. It's extremely useful, extremely easy to use. And what I would like you to do is, can you create a post method that will create a new bank account? Because currently we only have one bank account and we are not able to create new bank accounts. So can you create a post method that will create a new bank account that we can use then to deposit more money? I would like you to do that, and you can use this code as a base, but add new methods. And in future tutorials, what we're going to do is we're going to use Spring Data to remove all that JDBC stuff that we have there and do a more straightforward application of the database, because Spring Boot has extensions for database connections, and we don't have to do all that connection stuff on our own. We can use Spring Boot, and it's going to make it extremely easy to use. You'll notice right away the advantages of Spring Data. And there are other things that you can do. You don't really need to use Spring Data. You can use other frameworks which are very good as well. The Spring Data is a good one to get started. And then, yeah, we'll learn more about different extensions for Spring. So if you have enjoyed this tutorial for Spring Boot, I hope this has clarified what Spring is clarified what Spring Boot is, how it can be used, how easy it is to use. And yeah, if you like this video, like, subscribe, share, and leave a comment with feedback. All this helps me to get more videos going and to help this community grow. I really enjoy doing these videos, and I really enjoy knowing that it helps you to learn more about Java, about the software engineering, and so on. So thank you for watching, and I'll be waiting for all of you in the next video. Bye bye.